Okay, question 9. When water boils and turns to steam, there are changes in the arrangement of the particles in the density. Which of these shows the changes? So space between the particles should be larger, they're more spread out. So it can't be C or D. And the next part is the density. Steam should be less dense than water. So I'm hoping that's going to be B. Next one, figure 21, so it shows some water in a measuring cylinder and a lump of iron. So I'm going to lob that in there. The water will raise, we'll get the volume. It says the water level in the measuring cylinder rises to 530. So we can now see it's about reading that scale carefully. That's starting at 490 and it's going to rise to 530. So that's going to give us a change of 40 centimetres cubed. And it then says calculate the mass of the iron. So this is Dave's massive verruca, and mass equals density times volume. And the last part is two significant figures. So have a quick check of the units. Grams, centimetres cubed, no unit changes, which is handy. So first part, find the volume. So 530 is the new volume. It started at 490. Don't be lazy and read 500. That's 40 centimetres cubed. Now we want the mass. Mass equals density times volume. So put all that in as 7.9 and 530 equals 316 grams. But it wants it to two significant figures. That 6 is going to round that up to a 2. Done. A piece of wood has a similar shape and volume to the lump of iron. Explain why the method used in B cannot be used to determine the mass of the piece of wood. So you shove your piece of wood in there, it's going to float, and it ain't going to be easy to dunk it under the water. So you're not going to displace the full volume. So in words, wood floats, so you cannot fully displace its volume in water. Our idea is that it's going to be really difficult to fully submerge it without affecting the result. And now your favourite, you're really good at this. You did well on your mock. So we want to determine the specific heat capacity of water. So just to go through, Q equals MC delta T. We're going to get a mark for saying C equals Q over M delta T. So now we've got to know a way of finding out the energy. So that's a joule meter. Mass, we're going to need a balance. And temperature, we're going to need a thermometer. Okay. It now says, describe the method they should use. You may draw a diagram if it helps. So we're going to get a beaker. We're going to insulate it. We're going to get a heater. That's going to be connected to a joule meter. We're going to have a thermometer. We're going to have a measuring cylinder to measure the volume of our water. We're going to have a lid. And we're going to have a stirrer. Now that's a good one. That's it all there. And I'd label it if I wanted. But now I'm going to go through the model answer here. So find the mass of the water with a balance or using the volume in a measuring cylinder. So if I wanted this, the volume, I could weigh the beaker empty, then put my water in, find out what that mass is, because 1 gram equals 1 centimetres cubed. Or I could just use a measuring cylinder. Put a thermometer in to measure the temperature at the start and the temperature at the end of the water. Get a joule meter to measure the energy transferred by the heater. If you wanted to, you could use a ammeter and a voltmeter, but joule meter is easier. Get a stirrer to make sure we get the same temperature throughout the water. I've used the word homogeneous. Add a lid, insulation to reduce the energy loss. And then if we wanted to, could have a stop clock, we could time it, or we could say we're going to let it rise by 10 degrees C. Then we're going to use C equals Q over M delta T. Repeat the process 3 times and calculate a mean. Now it's not asking us to compare anything. If it was wanting us to compare different things, we're only after just C for water, which should be 4.2 joules per gram degree C. If it wanted me to compare things, I'd then have to reword this in terms of how I'd be repeating it, independent, dependent, and all that sort of stuff. But that's enough there. That's a good, and you're really good at this question.